This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 2 weeks. Thanks to our audience and the partners listed on our website for supporting the podcast. Welcome, listeners, to a new episode of Software Engineering Radio. This one is about Spring, and my guest is Eberhard Wolff. Hello, Eberhard.
Hi.
Of course, now that Eberhard, some of you might remember back in the old days, ages ago, Eberhard was part of the SE Radio team. And of course, at that time, we never could really talk about Spring because we didn't, now we can do it because he's not on the team anymore. So this is an episode about Spring, and obviously we try to focus on the technologies behind it and why Spring is interesting. But before we do that, Eberhard, please, for those that have forgotten who you are, please introduce yourself again to our listeners.
Okay, so first of all, thanks for having me on the show. It's really an honor. And I still feel somewhat sad that I had to quit SE Radio because, there was just too much stuff that I had to do. Okay, so my name is Eberhard Wolff. I'm the regional director for SpringSource in the German-speaking area, which is Germany, Austria, and the German-speaking part of Switzerland. So I'm running the operations there. And the other role that I have is I'm a principal consultant at SpringSource. So I do trainings, consulting, reviews, and all that kind of stuff. So that's where I come from. Okay. So,
I guess we should start with giving people an overview about what Spring is. Not in every detail, but just like a 10,000-foot overview.
Yeah. So basically, Spring is a framework, and it contains of 3 parts. First of all, there is dependency injection, then there is AOP, and the last part is service abstraction layer. So let me elaborate on those parts a little bit. So dependency injection is basically a technique that allows you to make objects know each other. While usually you would have a factory pattern, for example, to do that, in dependency injections, it's just set methods or constructor parameters that are filled up with references to other objects.
And there is the framework magic behind that does that.
Yeah, exactly. And the reason why this is a good thing is, first of all, it allows you to exchange those dependent objects for mocks if you want to do testing. And the other thing is that some things like, for example, if you want to get access to JNDI, which is a naming system that is used in Java EE environments in particular, you can hide away the details of such a system by just injecting some objects, and you don't have to care with the details of these techniques. So it's actually interchangeable. You can get objects from JNDI or you can use plain Java objects, and for that reason applications also become more portable, so you can run them on Java EE or on Tomcat or in your simple environment that you're using for simple tests.
But fundamentally, Spring is, let's say, an alternative framework for enterprisey kind of distributed Java applications.
The question is alternative to what?
To the official standards like JEE, EJB, these kinds of things.
You could integrate Spring, and in some areas I would argue that it's actually they are competing against each other. So for example, there are also dependency injection technologies in EJB 3, for example, but Spring is more powerful, and also you can integrate it. So you can still run your applications on Java EE servers, right, if you're using Spring.
So let me rephrase that. Spring is an alternative programming model for building enterprise applications that may or may not run on the infrastructure provided by JEE.
Yeah. And
I think we did an episode a long time ago on enterprise stuff. I think the future of enterprise Java, and you came up with this term, the enterprise operating system or something, the application server which provides the runtime infrastructure which is independent from the programming model.
Yeah, I mean the important part and what you have to think about is that Java EE is first of all not the predominant approach anymore. So because if you look at what people are really using out there, most of the people are using Tomcat, which is not a full Java EE implementation anymore.
Yeah.
And the other thing that you have to think about is that a lot of people are stuck with old Java EE servers because operations says, well, you know, we can't just do every update.
Yep.
And some vendors are even quite conservative in terms of the standards that they support. So I think one of the things that make Spring quite interesting is that it allows you to use more advanced features even on those rather old application servers.
Yeah, so it's because you have the separation of programming model, which evolves while keeping it compatible on the service provider side to old implementations of JEE.
Yeah, exactly. And that's why we have quite a few customers that are using Java EE servers but want to use the Spring programming model instead.
So you talked about dependency injection. The other two you mentioned were AOP and
template pattern.
Is it?
Yep.
Okay. Right. So I guess we've had episodes on AOP, so I guess you don't have to explain in detail what AOP is, but how does it play into Spring?
Well, the idea is that you can use it to implement things like transactions or security and add it to your business code transparently. The AOP implementation in Spring is nowadays compatible to AspectJ, so you can easily migrate your own aspects to AspectJ if you want to.
Yeah, for these huge amounts of people who have real systems built with AspectJ.
But it's actually the other way around. So I mean, people start using Spring, they take a look at AOP and say, well, that's actually nice. And then sometimes they say, well, but it's limited, so we rather want to go for AspectJ. So and I think that actually helps the adoption of AspectJ somewhat. So it's sort of a win-win situation there. So AOP is basically for Spring. AOP is the common ground on which declarative transactions, security, and all that kind of stuff is built on, and it allows you to build your own similar features as well using the same techniques.
So the granularity for the AOP is probably the Spring Bean, where the Spring Bean is, let's say, the smallest managed entity managed by Spring.
Yeah. Even though you can stretch this concept quite considerably. So if you look at Spring Security, for example, what you obviously want to do is you want to have specific domain model instances that are only accessible to certain users.
And with domain model, you don't mean managed beans that provide services, but rather data classes.
Yeah. So let's say you have a customer service, that would be a Spring managed bean.
Yeah.
And the customer service returns some customers, and you must not see the customers that don't belong to your region.
Right.
And you can actually implement that using Spring AOP, because what you just do is you target the customer service and you filter the results of each method call for the customers that you don't have to see.
So the aspects still advise the service and not the domain objects.
Yeah, even though
what would I do if I would want to say I can only see 3 of the 5 attributes of the customer? Can I also advise domain objects? Or I mean, I can do it with AspectJ low level wise, but is there a way in Spring to do this systematically, or would I just revert back to AOP in the sense of AspectJ?
Well, I mean, what you could still do is you could still try to use the same trick that says, okay, you stick to the services and you do additional stuff to the domain model. You could do that.
You would remove the contents of those fields when you hand them out.
Yeah, which might have nice effects if those domain objects are managed by Hibernate, for example, because the changed objects might be written to the database. Yeah. But in particular, if you want to add aspects to your domain model, I usually advise that you should think about using AspectJ, because especially these rather fine-grained aspects are more efficient if you use AspectJ. Right. And you also have a lot more that you can actually advise. So that it is just more powerful.
Yeah, because the advices are not limited, or actually I should say the join point model is not just the bean boundary, but rather all
Everything,
the aspect J low level Java grammar abstraction.
Everything, yeah. So basically, as you said, using Spring AOP, what you can do is you can advise Spring beans and change them. Using aspect J, you can change everything that somehow runs in the JVM. And the way it works is that you either have load time weaving, so you do some manipulation on the class loader. There is actually support for this kind of abstraction in Spring. So Spring can help you to tweak your class loader to do that. Or you use a different compiler, so the aspect J compiler. So that's sort of the trade-off. So if you get Spring, you have Spring AOP out of the box, which is, so it's easier to use in that respect, because you just use Spring and you have Spring AOP out of the box. While if you want to go for the more powerful model, you would have to change the compiler or tweak the class loader, which is for some people a hurdle. So, but then you could use aspect J. That's the idea.
I tend to think that from a design perspective, it is useful to try to limit the AOP magic to component boundaries. But I mean, that's just my opinion, if possible.
Yeah, that's actually an interesting topic, because in particular in trainings, or if I do a presentation about Spring, I get a lot of questions around, well, how do you keep your aspects from messing up the code? And my impression is that what you can do using AOP is that you can add specific behavior to certain parts of your architecture. So you would say, well, every service that I define will have a security check. Every DAO that I define will have a certain transactional behavior. And if you use that approach, I can't see how you can actually mess up your code using aspects, because at the end of the day, that would just mean that you don't know what your architecture is like. So that's basically my idea about that.
Okay, so the third ingredient, fundamental basic ingredient of Spring, in addition to dependency injection AOP, which we talked about, was the template pattern. What's that?
Yeah, that is part of the enterprise service abstraction that is in Spring. It's probably the most important part. So the idea of the template pattern is that you pass in certain code that should be executed, and this code then gets some resources like a JDBC connection, a JDBC statement, or a JMS resource or whatever, and executes using that resource. And you don't have to clean up the resources.
A little bit like as if you could pass, if you had closures, then you would pass in a closure to a service method that acts, right? Is that what you're talking about?
Yeah, absolutely.
So it's an emulation for closures.
It's not about the closures. I mean, the emulation of closures in Java obviously are inner classes, or anonymous inner classes. It is an environment that allows you to use those to pass in resources to such, let's say, closures or inner classes or whatever, and through that you don't have to handle those resources yourself.
Right. Yeah, okay.
I mean, it's quite interesting to take a look at, for example, JDBC. Not too long ago, I've read a tutorial in a magazine for JDBC, and it didn't talk about how you can probably clean up your resources. And in real life, in real enterprise applications, that's a big no-no, because you will end up with resource leaks, and your application will sooner or later, not work anymore. But these template patterns are just part of the general abstraction. So we have some more abstractions there. For example, there is a common abstraction for all the transaction APIs that are out there. I mean, it's quite interesting to see that a simple thing like a transaction that is basically just a commit or a rollback plus a begin can be done in so many different ways as we have it in the Java platform right now. So there is an abstraction layer there as well to sort of clean up the mess that has been created there, and so on and so on.
One way of doing that, as I understand it, is the use of annotations. I mean, classically, you would have written a beans XML, a configuration file that basically specifies which instances of which types you have and how they're injected in the sense of dependency injection. More recently, you have gone over to the annotations side. So can you explain a little bit which role annotations play in regard to dependency injection and also in regard to AOP?
Oh yeah, sure. So what we've done in Spring 2.5 is support for annotations for dependency injection was added, as you mentioned. So you can annotate a class and say, well, this is a Spring Bean, so it will automatically be instantiated as a Spring Bean. And you can also define the wiring between the beans using annotations. This is not unparalleled. I mean, EGB, for example, or EGB3 has similar features. It is interesting to note that a lot of people still stick to XML, and one of the main reasons they give is that they have a configuration file that sort of gives them an idea about the structure of the application, which I find interesting. Because in a lot of, you could argue if you have, let's say, a service plus interface plus an implementation, it's quite easy to guess what will be injected if you want to get access to an instance of the service interface. It's going to be the service implementation. So it's not that hard to guess that. And that's what probably the XML will contain of. But anyway, I mean, we have added this annotation support. It's an alternative. I wouldn't say it's better or worse than what we have in XML. It's just a different approach. And using in AOP, you can use AOP for you can use annotations for the point cuts. So
like you would advise all classes or methods that have the following annotation.
Yeah, so, and I think that's basically what it boils down to. I think what it boils down to is you can define your architecture. So you can say, well, a service is something that is annotated as add service. And then you would say, okay, well, AOP will add security transactions and Spring dependency injection container will turn that into a Spring Bean, but you might as well do the same thing using naming conventions. So you could say everything that where the class name ends in service impl.
Well, yeah. The difference is, of course, that annotations are their own types, so you get some type check. If you have a typo in your impl thing, suffix, nothing happens. If you mention an annotation that doesn't exist, you get a compiler error. So it's a better typing.
Yeah, I'm not saying that one of these approaches is better than the other. What I'm basically trying to say is Spring is about flexibility. So if you want to go for annotations, fine. Yes. If you don't want to do it, there are alternatives.
Understand. Yeah. So, but you also use annotations, and I guess we'll talk about that later if we talk about the Spring universe, as you've called it. You also use annotations as a way to mark up Spring Beans with all kinds of additional information that then is used by various frameworks like web service, REST, or something else, where you look at the annotations and then the framework does some magic behind it. Maybe implemented as AOP, maybe not.
Well, there are, if you look at Spring integration, for example, there are some annotations that are defined there. There are obviously some standard annotations, like in JAX-RS, for example.
What's JAX-RS?
That's a standard for REST implementations in the Java world. But those are evaluated not by Spring Core, but rather by these other frameworks that support JAX-RS or Spring integration or whatever.
Yeah. So I guess we've covered the core of Spring. I think we should take a look at the Spring universe. Can you give us a couple of representative examples of additional Spring facilities on top of the core framework?
Yeah. Basically, what has happened, and that's an ongoing process for quite some while, is that we thought that there are other areas in the Java world that also could be done differently, better, or where we have a specific approach. and that ended up in creating more and different projects that are somehow related to Spring. They often do use the container, but in some cases, like Spring Security, for example, you can actually use it without using Spring itself. So Spring Security, for example, can also be used with AspectJ or without any AOP implementation whatsoever, or based on just servlet filters. So it's actually a little bit more flexible. But basically, you're right. It's stuff that has been added to Spring to take care of specific areas.
So let's walk through a couple of examples. I think let's start with one that's maybe not so hyped because nobody talks about batch processing. But you have a module, or how do you call these things? Add-ons, modules? Projects called Spring Batch.
Yeah.
What's that? What's the architectural abstractions behind batch processing as you see it in Spring Batch? Or what's the challenge in batch processing? Maybe we should say it that way.
Yeah, probably we are too young to realize where the issues are. So I think Spring Batches is one of the more interesting projects because it fills a gap that is actually very apparent if you think about it, and is very interesting to a lot of companies because there is batch processing. There will always be batch processing, and there are quite a few projects based on Java that want to do batch processing to switch off mainframes, but also because the things they are doing are done daily, so they have to do it in a batch, or they have to print out invoices, and you can only do that sensible in a batch, and so on and so on. So I think it's a very interesting thing that nobody had the idea to support that kind of stuff before we did that. So you ask about the abstractions that are there. So basically one of the issues around batch processing are first of all that there are some optimizations. So you don't want to do a commit for each and every data set, but you rather want to pile them together and do a commit for, 10, 100, 1,000 or so. Yeah. And the reason for that is because the transaction on the database is somewhat of an overhead, or adds quite some processing time to the database. And if you want to implement your batches in a performant way, you just can't commit each and every data set. That's just not possible. So that's one example. The other thing that is pretty hard if you don't have a framework that helps you is restartability. So if your system crashes and it's a 1 hour batch, you have to somehow be able to restart your application. There are obvious ways how you do that. So, I mean, you can store the status of your batch in the database and then restart the batch from that specific point. So that's also automatically supported in Spring Batch. And another thing is parallel processing. So you want to do parts of the batch in parallel, multiple parts in parallel, to become more efficient or faster. So if your system is scalable, then you get more performance if you do more stuff in parallel. And that's something that has been added in Spring 2.0.
So one problem you have if you have interactive applications on one side and batch applications on the other side is that you sometimes have to duplicate business logic, because in the interactive case you basically write the code so that it handles only one case, and in a batch, for example, you do a bulk update, right? And then if you do the bulk update with an SQL statement that's custom made, then you kind of bypass certain application logic that you've put into your beans through which you would normally go. So is there any support to resolve that problem? Will the batch processing also use the services defined in the beans? Or, I mean, I think that's one of the central issues, isn't it, with batch?
It is certainly one of the interesting issues around batches. And what you can obviously do is you can use the same business logic for online as well as batch. And in one case, you would just use it using, I don't know, Spring MVC or something, some web front end. And in the other case, you would run the same logic using Spring Batch.
But it would still mean that, let's say I have customers and I want to update their status to be X for all customers that have paid an invoice this month. Okay, so you would do this if you did it in real batch processing, you would write one SQL statement, right? Whereas if you do it with Spring Batch going through the services, what will happen on the database is there will be probably first you get a cursor or a set of data objects, and then you update them sequentially, each one at a time. So there's no way around that, is there?
Well, to give the typical consultant answer,
it depends.
So if you look at Hibernate, for example, what it does is it does batch updates, and it does them if you close the session, which in Spring is by the end of a transaction.
Okay.
So using the Spring the Spring batch transaction integration, you would do a batch update by the end of the transaction, which would contain all the different items that you've touched during that transaction.
Okay.
So technically speaking, there are ways to do that, and in particular, if you have a separate business persistence layer, it should be easy to do that.
In other words, you would rely on the persistence layer to detect that there is a bunch of updates that could be done in one fell swoop instead of doing them
or add some special case. So if you have a JDBC based persistence layer, you would probably add a specific case. However, I mean, what you are assuming, and I think that's the interesting part, what you are assuming is that the same business logic is executed in batch and online.
Well, not really the same business logic, because the use cases are obviously different. Otherwise, you wouldn't have it. But the same constraints, the same checks, the same consistency rules, and so on probably apply.
And I'm not sure. I mean, I've done some batch processing even before joining SpringSource using Java, and I'm not sure whether that's actually really the case.
Okay.
And if you think about it, I mean, if let's say you have an online shop, so someone issues an order in your online shop, you're probably going to do quite a lot of checks that say, well, is the credit card valid? Is the address valid? And I don't know what else. And you will also give the customer some feedback that says, well, this is not really, it's not on stock, so you have to think about something different here, or here's an alternative and whatever. And particularly this thing about the alternatives and the decision that the customer might make is just not an option in batch.
Cool. Yes.
So I'm actually wondering, and I think it depends on the case at hand, whether the idea that you can use the same business logic is actually true. Not so much because of technical constraints. I would think that you can somehow work around those, but I'm really wondering whether it's the same functionality that you want.
And I guess if you have certain constraints that need to apply in both cases, then putting them into the database, if possible, is one way to go. But okay, let's stop this. Another module another thing that I find very interesting is DM, dynamic modules, the integration between Spring and OSGi. We've had an episode on OSGi. I guess for our discussion here, we can define it as a fancy modular class loader, or isn't that doing it justice?
Well, I would think it's two parts. So basically, the idea is that you modularize your systems into bundles. That's basically jar files with some specific stuff.
So, and with modular, I think modular, the term is ambiguous, because the beans already modularize your system. Various application contexts also do it. So it's a runtime modularization, isn't it?
Well, we should talk about that later on. Okay. So basically, the idea is that you have a set of classes, like in an Eclipse project, that would, and the result of that would be a bundle. And this bundle might import or export specific packages.
Right. Okay.
And the other thing that you can do is you can export and import services, which is basically objects.
So it's a higher level visibility mechanism on top of Java packages.
Yeah.
And then there is the fact that at runtime you can dynamically load and unload those bundles that also serve as visibility. Okay.
Exactly. But the main point is there are bundles. Bundles might import or export packages or services.
Right. So, and which of those two features that we just mentioned is exploited in Spring DM?
Well, it's export and import of services and packages, so it's actually 4 features.
Okay.
But anyway, so the most important part, I think, or how it fits into the Spring picture is using Spring and Spring dependency injection in particular, you can define how objects are wired together.
Right. Yeah.
And the problem is it's done in a flat namespace, which you could work around somehow. And there are also no clear visibility rules, so you can't say this is a bean that I want to export to a different bundle or whatever, to a different module, and this is my private inner bean. You must not use this, which is key, as you will probably agree, to a proper component system.
Yes.
So the way this works, basically the idea is, well, we have bundles. Each of those bundles has its own Spring configuration, its own application context. There are some beans that are public, and they will be exported to other bundles, and there are
which means that will become an OSGi service.
Exactly. So basically, those sort of public beans are the OSGi services, and you can also consume OSGi services. So by that, you can wire together your system of bundles and those sort of public beans that are OSGi services.
So let's take a look at the situation within one bundle, okay? You say within one bundle there is one application configuration, which means that within this one bundle you have the usual Spring dependency injection, no questions asked. Right. Now we have 2 bundles, and there is the one bundle, let's call it B, which which makes a couple of its beans public as OSGi services. How does the other bundle, A, how does dependency injection work with those services? Will it inject the service references into those beans, or how does this work?
So the way it works is that a proxy is generated and this proxy is injected. So and that's actually quite nice, because the problem, as you mentioned, is that bundles might be installed at runtime.
Yeah, so OSGi has this whole dynamic worldview. Everything can go and come as it wants.
And the way, by using this proxy approach, what you can do is, if your service all of a sudden disappears, you just buffer the method calls to that service and wait until the service reappears.
But that's hopefully configurable.
Yeah, sure. You could also define a timeout if you want to.
Okay,
but
nice.
That's basically one of the parts.
Okay.
The other thing that is interesting here is, if you are smart enough, you can actually build a configuration that allows you to run the system with or without OSGi. So the way it works, let's assume there is a bundle that exports, let's say, a customer DAO to access customers in the database, and there's another bundle that has a customer service that uses this customer DAO. The way it usually works would be that the customer service has a reference to a Spring bean that is such an OSGi proxy, and then the customer DAO is exported as such an OSGi service. What you can do, if you, as I mentioned, if you're smart enough, is you can leave out the middle part that exports and imports the OSGi service, and you just stick together the OSGi, the customer service and the customer DAO directly, and that way you don't have the
proxy.
You don't have the proxy, and you don't have the dynamics anymore,
right? But
your system still works, and you could run it on Java E if you want to, or on a simple Tomcat if you want to. So that's also quite cool, I would argue.
Yeah. So so is OSGi, how should I say this? Is it just an add-on, or is it something that you guys consider a really useful and important ingredient? Kind of, because I mean, Spring doesn't do anything about the runtime dynamics, whereas OSGi does.
Yeah.
So I think it's a nice complement. So
yeah, absolutely. I mean, if you look at what we are doing right now, So what Spring Source has done is we have added support for, we have commercial support for Tomcat now, and we have a version of Tomcat that is actually good for larger cluster installations. That's sort of the traditional runtime environment that you could use for your Spring applications or any other applications that you want to, which is sort of a limited Java EE implementation because it just sticks to servlets, so it's more lightweight. The other thing that we have, and that's important concerning OSGi, is the sort of next generation runtime environment, which is the DM server that is based on OSGi, based on dynamic modules, and adds some more stuff like support for Hibernate, some other advanced features, support for load time weaving, and so on and so on. And that's also an open source project, and it actually proves, or it actually tells what we think how important OSGi is. We have also an initiative to put out OSGi compatible versions of a lot of libraries that we offer.
So in some sense, you're replacing, let's say, a JEE-based runtime environment with an OSGi-based runtime environment.
We offer that as an option, as an deployment option.
My question would be that JEE does a lot more than more or less dynamic modularization. It also comes with load balancing. If you do it the right way, it provides monitoring and other things that you get as part of an application server. OSGi doesn't have that. So my question is, do you position OSGi and JEE as competitors in the same space, or do you say there are some environments where you need the big fat JEE, and then it's good that that it is there, and for more lightweight environments you use the OSGi runtime, or what's your position there?
So to take the concrete things that you've just mentioned, so load balancing is not a problem because the M server has Tomcat, and I think that the scalability of Tomcat is well known. We also provide monitoring support for that for the M server, so there are parts of that.
So in other words, you've rebuilt an application server on top of OSGi.
Yeah, it's which is focused on web, because again, the important thing is, if you look at the statistics, most of the projects, I think 70% or so, are done on a pure Tomcat environment. So the reality is that Java EE is not the dominant application platform anymore. That's just not what we see.
Unless you count a pure servlet implementation as JEE,
and it's
some
clearly
communities tend to do.
And even if you look at the full-blown Java EE servers, in a lot of cases they are just used as a servlet container. So what it boils down to is that we think that you're much better off using these lightweight environments because they're easier to administrate, easier to work with, and that's what we are focusing on. There are, of course, some minor cases where a Java EE server might add value, but the broad majority of people is not using Java EE server anymore. It's just not what they are doing.
So since we're talking about the web already, there is also support for web applications specifically in Spring. And what I find interesting is that not just is there a huge load of web frameworks in general in the Java world, there is even a huge load of web frameworks within Spring. So which one is the one that should be primarily used today, and how do they play together?
I would argue that, again, the consulting answer is it depends. So I think there is a variety in web frameworks in the Java space for a reason, and they are tied to specific cases. First of all, let me say that Spring actually has support for quite a few web frameworks. So if you don't want to use our own web frameworks, that's perfectly fine. You can still use Spring for dependency injection, AOP, and so on. Our own web framework. So first of all, there's Spring MVC, which is a model view controller framework, much like Struts. Basically, a request comes in, is the controller handles the request, fills up data into the model, and that is then rendered by the view, which is more or less what Struts also does. So it's in the tradition of Struts, but with a much easier and better approach, I would argue. The other sort of basic technology that is out there and that we think actually makes sense is, or that we directly support, let me put it that way, is JSF, because it's a component-based model. So JSF, you have components like a button or some text field or something, and you have beans that handle events that are done on those widgets, which is pretty much what you do in Swing as well. Yeah. And that's a better alternative if you want to go for richer, environments. So
what does Spring Faces add to JSF?
Yeah, Spring Faces, it's actually twofold. So first of all, it's an integration between between JSF and Spring Webflow, as I will explain later on. The other part of Spring Faces is a component library that is based on Spring JavaScript, and that Spring JavaScript allows you to add decorations to widgets, to normal HTML widgets, basically, for validation and for pop-ups and that kind of. Yeah, basically that's it. And based on that, we have Spring Faces, which has some JSF-like components for that. And there is also, so if you look at the frameworks or our view on the frameworks, basically there is request response, simple stuff that you would do using Spring MVC. And Spring MVC is enormously flexible, so it's also the basis for the integration of web services and so on into Spring. And then there is the component-based approach in JSF, which has a different area of excellence. And then on top of that, you can add Spring Webflow to model flows. So multiple pages that can build up on each other. And the nice thing about Spring Webflow is, first of all, you can actually define those flows as a first-class citizen. So you even have a graphical editor for that. And there is also variables can be stored in the flow. So it's quite easy to have 2 browser tabs and handle an order in each of them is a different one, and they don't interfere with each other. And you can also add the back button for back button handling is much easier, and so on.
It's a little bit like conversation kind of things.
Yeah, the difference is in conversations is usually just an API that says here the conversation starts, here the conversation ends. In Spring Webflow, the idea is that you have a flow that you can even model in a graphical way, and the conversation is just naturally a part of that flow. So I would argue it's more elegant to do it that way, but I'm biased of course.
Well, everybody knows that you're biased. So I should. Eberhard is biased. Don't believe any word he says. So I guess there is one big topic we didn't talk about, and that's the web services and REST support, right? Remote communication in general. I remember that back in the days when I used Spring, you could export any Spring bean using a number of frameworks and make them remotely accessible. And I guess in the enterprise space, remotely accessible these days means web services or REST. You want to talk about that? Yeah, sure. So there are 2. So the REST support is actually something that we've added to Spring MVC, which is part of Spring Core in 3.0, or let's say that we are currently adding there. It is, what I think is quite interesting there is that it's a very simple addition to what we already had in Spring MVC. So there are some fundamental parts in Spring MVC that now pay off. So for example, Spring MVC is quite flexible in terms of how it renders a model. So using Spring MVC, you can render a model as an Excel spreadsheet or as PDF or whatever. And for the REST support, that's quite nice, because in REST, the idea is that you can access data and you can have it returned as JSON, RSS, Atom,
XML or whatever. And it's quite easy. So there's a class now added that is called content negotiating view resolver that allows you to render a specific view based on the accept header or the file extension of the URL.
View being basically a content type then, like
view,
XML text.
Yeah, that kind of stuff. Something that is able to render some HTML response basically, or HTTP response. Sorry.
Yeah, HTTP, yeah.
And the other thing that we added is an annotation that allows you to extract parts of the URL and put that into one of your method parameters for a control.
Again.
Yeah, so you can annotate the parameter, the method parameter, and say, well, please add the last part of the URL here. So if you have a get for, I don't know, some URL, customer 42, then you would get the 42 into the parameter, and that makes it quite easy to build REST-based systems then. So that's what we are going to do in Spring MVC 3.0, and I think it's interesting to see how, if you have the right abstractions, new features like REST are actually not that hard to add, but they fit nicely into this
in the existing model.
Exactly. Yep. So that's what we are doing there. You also talked about Spring Web Services. Spring Web Services is actually a separate project. And the reason why we didn't stick to the existing Spring, to the existing web services systems is because we wanted to focus a lot on contract first web services. So what you do using Spring Web Services is you define the contract between the client and the server using XML schema, not WSDL. And the nice thing about, and the WSDL can be generated from this XML schema-based sort of data definition.
Well, but that means that the WSDL is basically only saying, I accept an instance of that schema and I rip, right?
Yeah.
Because
yeah, but the nice thing is that you don't have to write this WSDL overhead anymore. And the other nice thing is that you're independent from SOAP. So, I mean, you could use the same XML schema to validate REST as well, or you could use it to send XML over JMS or whatever.
Right, exactly. I mean, that's the point. I mean, web services these days is basically HTTP-based XML messaging, okay? You define your messages as XML schemas, and then you exchange them using HTTP. And as you say, you could just as well exchange them using any other JMS or something else. So I think it's a good idea to forget about WSDL and this SOAP stuff.
Yeah, exactly, and that's sort of the what makes Spring Web Services unique. That it focuses on.
Why didn't you call it Spring XML messaging? I mean, seriously. I mean, isn't that what it is at its core? Or am I missing something?
Maybe because of marketing reason.
Okay,
I don't. I mean, at the end of the day, it's still a tool to implement web services. So I think the name is actually quite nice.
Yeah.
So
I guess I have one more question that I would like to put at the end. So is there anything else that we forgot to talk about? Anything else that's coming up that you maybe want to mention? Okay, so let me think. So we've talked about Spring Security somewhat. So basically the idea there is to add security to your applications using AOP or Spring or software filters, which makes it the only I think even the only framework that allows you to do that, to keep your code clean from security issues and adding them later on or as a separate aspect, which I find interesting because, I mean, AOP is pretty well known, actually. It's actually, I think, one of the good use cases for AOP, I think.
Absolutely, and that's why I'm a little bit confused that there are not too many other frameworks that do that. Then we have Spring Integration that allows you to do integration logic. So
what's that?
Well, there is this book by Gregor Hope, and I think you already had him on the show.
Enterprise integration patterns.
Yeah, and basically what this framework does is it gives you a way to implement those patterns, and the that is all based on pipes and filters, basically, right? So there are pipes that handle messages, and the filters, or pipes that send messages, and filters that handle them and process them in some way. And that's also the sort of metaphor that is in Spring integration. And the pipes in that case are in a JVM. So in the simplest case, it's just a method call that is directly passed through, or they might also be asynchronously. And there are adapters for outside JMS file, HTTP, I don't know, other approaches. So that's sort of, basic overview of the Spring universe. Not sure whether we forget anything. So shall we continue to what has changed? So what currently at the time of this recording,
which is July 7th, 2009.
Still work is still underway on Spring 3.0. The new stuff in Spring 3.0 will be REST, as we already mentioned. Then there is EL, expression language. So that's actually somewhat of an interesting story, because it's one of the very first enhancement requests that Spring ever got, was to add some kind of EL support into Spring, so that you don't have to just configure, basic string literals or numbers or stuff like that, but rather advanced things like EL expressions.
So in other words, if you have an XML file that specifies what to inject into a bean, then the string you put there can be an expression in EL that's then interpreted by an EL interpreter as part of the injection process.
Exactly. So what you could, for example, do is, if there is a data source, a database connection pool, the JDBC URL, you could write an EL expression that says, take something from the system properties. So, and then, or take value X from some separate bean or whatever. That's basically the idea. I think that's going to add quite a few interesting use cases, because it changes the fundamentals of how Spring configurations can be written, right? So that's the idea there. Then we will add support for model validation based on JSR 303, so that you can annotate your domain classes, and if you display your domain objects using Spring MVC on the web, you will get a validation will occur based on those.
What would be an example for such an annotation that validates? Like integer range must be between 0 and 3, things like that.
Or not null.
Right, okay.
Name must not be null.
Okay.
And then you will get a message on the web front end that says, well, the name was null.
Right.
Not a good idea. We will support JDK Java 5 Plus, so support for JDK 1.4 will be dropped, because that has been end of life. We have some new stuff. So first of all, there is Spring. There used to be a project called Spring Java Config. The idea of Spring Java Config was to basically take the XML file and do the same thing using Java.
You mean like in EJB 1.0? You remember when you wrote the deployment descriptors in Java?
No, you never did that. They were serialized Java objects, right?
Yeah, but you wrote them in Java code. Set transactions.
No, one of the authors of Spring, the original authors of Spring, wrote this nice book about J2E without EGB, which is what is happening right now, right? I mean, people are using Tomcat and not EGB containers anymore, so they won't make the same mistakes. No,
sounds like it, but okay.
No, I'm pretty certain they won't. So the idea there is that it sort of looks like a factory what you're implementing. So you're generating some code that says, well, generate a data source, please, and set the username to something, return the whole thing, wire it together on the DAO and so on. But the Spring Bean semantics still apply. So if you define something as a singleton, it will only be created once. If you say this should be done lazily, or if you say this should be in a specific scope, like the HTTP session, for example, that will also be taken into account. And that's, well, the sort of third alternative to configuration, the third basic alternative that will be there in Spring.
XML and annotations and Java programmed.
Yeah, and that's basically it. There is one minor feature that I think is quite cool, and also continues this theme about that you must know what your architecture is like to use Spring properly. So that's the concept of MetaAnnotations. So if you do your development in Java, nowadays it sometimes happens that there are actually more annotations than real Java code. And the reason for that is that actually some annotations just belong together. If you're defining a service, as I mentioned, you will probably want to have security checks, transactions, and you want to make it a Spring Bean. You probably want to have a specific scope. And what was added is something that is called meta-annotations. So what you do is, and I guess you like that expression just because it says meta. So
actually, I think it's not a very good name, but okay.
Yeah.
It's more like macros.
Well, it's annotations on annotations. So what you do is you define your annotation called my own personal service, and you annotate my own personal service with add transactional, add component, and other Spring annotations. And every time you use add my cool service, it will be treated as if all the annotations would be present on that class.
And the reason why I said it's more like macros is that those annotations you annotate to your own annotation, they don't affect the annotation you write, but rather if you apply your own annotation to a class, that annotation is kind of expanded and kind of replaced with the 4 or 5 annotations that you put.
It's not really replaced.
No, so but I mean the semantics as if it were replaced.
Yeah, sure. But I mean, meta just says that
it's an annotation on an annotation.
Yeah, so that's basically all. Yeah. So in a way, you're right. It's not. I mean, if you come from the modeling perspective, that's probably different.
Okay. So 2 questions to finish this. One is there any story between Spring and Scala? Because I mean, this whole expression language stuff, which basically means you put your expression language into a string, you have no tool support. And I mean, also you talked about this template stuff, which is a kind of closure which Scala has natively. Have you thought about doing a Spring.Scala thing where you exploit Scala's features to make Spring more programmable?
So first of all, concerning tool support for EL, I would be surprised if we don't support EL in one form or another in the Spring Source tool suite sooner or later, which is free. So it's a free Eclipse distribution that you can download. Actually, I'm not aware of specific support for Spring in Scala. I would
the other way around. Specific support for Scala in Spring.
Yeah, whatever. I mean, some kind of project that, for example, allows you to use templates with higher order functions and that kind of stuff. I'm not aware of such a project. If there is one, I'm certainly interested to hear about it. I personally didn't really dive into Scala that much, and we as a company have bought G21 not too long ago, so we sort of positioned ourselves in the Groovy Grades area rather than the Scala area. Okay. But I mean, still, if there is any project around, I would certainly love to hear about it.
Yeah, so would I. So guys, listeners, you know how to reach us, team@scradio.net. And I'll forward it to you.
Great.
Last question. Spring is an open source project. However, there is this big, powerful company behind it. So how many of the Spring developers are non-Spring source, or how does this work? I think recently there was this conflict kind of thing where Spring source made certain, I think, bug fixes people had to pay for or something. So what's the open source story here?
Well, the open source story is that Spring is an open source project. It will always stay that way, and we won't change the policy, the license. That's also what our CEO, Rod Johnson, said in his blog. I would argue that if you think about it, one of the hurdles that open source has to take for usage in companies is the question, where do you get support? If there are just some people who develop an open source project and there is no one who can actually stand up and say, okay, well, we are going to give you this kind of service level agreement, we are going to support you in that way, it's probably not going to be easy to use it in a professional environment. This is not related to the quality of the open source project or anything. It's not about whether this support will actually be needed.
Well, you need somebody to blame if you're a big company.
That's what it boils down to, exactly. And I mean, that's also why, if you look at commercial software, why most of the time you have some kind of support contract. There were some miscommunications, in particular miscommunications about the maintenance policy. That's already, it's more or less a year ago. And we actually changed it as well. So let me give you an idea about what the current policy says. If you look at open source again, at other open source projects, it's quite common for the projects to sort of go for the next version and invest all the resources in the next version. And I think that's pretty, I mean, it's completely understandable, and it makes a lot of sense because you want to innovate and you want to do the new cool features and so on. However, what this means in a professional environment is that you better go for each and every new version, and you cannot, I would argue, you cannot afford that. In some cases, I mean, operations people will just say, well, this is not an option at all. We have to stick to the old version. So what we have done now is we have a policy in place that says each version of Spring will be supported for 3 years. And each major version, there will be binary releases for that major version until the next major version comes out. So if Spring 3.0 comes out, we will continue to provide binary versions for Spring 3.0, as would any other open source project as well. However, the add-on that we have because of the commercial support is that you can also stick to 2.5, and you can get binaries from us if you have a support contract. The
so
source code...
You have people pay you for doing the boring work of keeping the old stuff alive.
Of just providing binaries of the old stuff.
You don't do anything with them.
Well, there are patches applied, and the stuff is updated constantly. And all the changes go into the open source repository. So basically, if 3.0 is out and you want to stick to 2.5, you can stick to 2.5 and compile your own binaries, or you pay us and we provide you with binaries. And those binaries, by the way, also are also enhanced so that you can get more monitoring information. And we actually do that using SpecJ compile time weaving. So the code is compiled using SpecJ, and you get a lot of information about how many transactions were going on and how long it took for the views to be rendered, and so on and so on. Okay,
then I guess thanks, Eberhard, for being on the show.
Yeah, thank you for having me on the show.
Sure.
Thanks for listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig Reddit Delicious links and the /dot button. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsive Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.